than 50, graphing inequalities with two variables. We will be able to sketch linear inequalities with two variables. Does anyone know what the symbol, Roman numerals, the symbol for 50 is? Oh my God, someone guessed straight away. We're gonna guess. Is it L? I don't know, we'll find out. I think have I asked you guys this question? I feel like I've asked you this question before. All right. Now the main difference between this and so it's just stuff that I do in church. Okay, cool. So the main difference between this and the last lesson is we're looking at two variables. So not just one. That means we're looking using X and we're using Y. That means our lines are no longer going to be straight. We may start getting lines like this. Now, to go along with the answer today's really quickly, today's fact value is correct. It is L. It's actually thought that originally it was a VI, so like a 1-5, sort of trying to represent it's a 5, but like the next level of 5, so like 50. And then this symbol sort of turned into this sort of shape. And then they just dropped off. They kept getting scribbled and looked wrong, so they kept trying to use L. So that's how L became the symbol for 50. And V is the symbol for 5, and of course I or 1 is the symbol for 1, 2, 3, and yeah, so on and so forth. So yeah, and the other symbols for 1,000 and 100. 100 is easy. It's C because cent, centurion, cent, like 100 cents makes sense. But for 1,000, it's M. It's a millennium. So M for millennium. You know, even though millennium makes me think of million, which is not the case, but it doesn't matter. Roman symbols I kind of like. I kind of like how they're symbols that we know, but they're also really, really old. So anyway, not important. Let's go back now to what we were doing last lesson. Last time I had you guys, what we did was we talked about, well, let's go back 2 lessons ago. First thing we talked about was these symbols. And then what we did was we jumped into plotting them on graphs. So we've learned how to simplify an inequality into just X and Y and plot it on a timeline or a number line. So and we did the same thing when we had 2 variables. So even though we've got 2 here, we can still do it. We just got to make sure everything we do to the left, we do to the right and the middle. So you got to make sure you do everything to the same side. And then what we did was we did a piecewise graph, but this piecewise graph actually had 2 shapes to it. It actually looks something like this. We had a line that went up, and then we had an open circle, and then we had a line that was up here. We had a closed circle, and then we had a line that went down. And the idea was that I said to you guys, this is still a piecewise graph, but it's not connected. It's what we would refer to as non-continuous. And what I wanted you guys to understand is that these symbols greater than or equal to are important. So when you say a symbol, when you say something is greater than, that's implying that, you know, it doesn't, less than, it doesn't include that point. That's why it's an open circle. When it's greater than or equal to, that means it does include that point, so it's a solid circle. Now, what I then did is I then showed you guys, hey, you can represent this value by drawing a line at -3, a line at 1, and then the region that we want is left unshaded. And I'm going to start using these keys more often. So the region required is blank. That's what this square here means. Now, And then I'll set you guys off to do 12A, B, and C. 12C is where a lot of these questions came up. The 12D is when you start looking at them in 2 dimensions. So what do I mean by 2 dimensions? This is what I mean by 2 dimensions. We've got an X dimension, oh sorry, not 2 variables, sorry. We've got an X variable and a Y variable. And what I want to check first is just some basic, I want to check some basic maths just to make sure that we know how to do the basics of questions like this before I jump into 2D. So I'm going to have another sip of my coffee. Okay. 5x take away 3y must be greater than or equal to 12. And here's the question. Is 2, 3 in this region? What that means is 2, 3 a satisfactory solution to this equation? And if it is, then that means that it would be in the required region. It would be white on our graph. So let's do this here. Hold on a second. Let me just figure something out. 1 second. You guys can write down the bottom question if you want. Okay, so how we do this is the same way that you would expect to do this with any old question. Is we're going to substitute 2, 3 into this equation. So I'm going to give that a try. Oops. Now, so what I'm going to do is I'm going to go. So if this is 2 and this is x and this is y, so what I'm going to have is 5 times 2 minus 3 times 3 must be greater than or equal to 12. So that's going to be 10 minus 9. And 10 minus 9 is going to be equal to 1. Is 1 greater than or equal to 12? No, it's not. So therefore, we would say it's not in the region. Whereas if it was like, you know, if we were talking about, if it was 13, if we had something more like 3, 0 or 5, 0, whatever, then it would be in the region. Down the bottom here, we have a worded example of the same question. I can't remember why I included a worded example. This might be because it pops up in the exercise. So I thought, yeah, I better show you guys a worded example just so that you guys can see it. A circuit needs 12 volts to operate. We have X 3-volt batteries and Y 6-volt batteries. Will the circuit activate when X is 3 and Y is 2? So in other words, can we? And it's pretty much it's almost the same as the question above. Actually, it's kind of interesting. So how do we calculate this one down the bottom? So what we need to do for this one is I'm going to show you guys how to create a an equation like the one at the start, and then what we'll do, we're going to show you how to create one like this, and then what I'm going to do after that is we're going to solve it. So we know in this equation the circuit needs 12 volts, and you've got 3-volt batteries and you've got 6-volt batteries. Now, how we can write this down is we can actually have, well, if we have X batteries and we've got X 3-volt batteries, so that means if I had one X-volt battery, I'd have 3 volts. If I had 2, I'd have 6 volts. 3, I'd have 9 volts. 4, I'd have 12 volts. If I add on my 6-volt batteries, so in this case, we've got 6y. So if I've got one 6-volt battery, then it would be 1 times 6. But two 6-volt batteries would be 2 times 6. And we need it to be at least 12. So we need to be either equal to 12 or more than 12. So what I do is I do a symbol like this, which just means that this needs to be greater than 12, or it could actually just equal 12. So because it could be just equal 12, I'm going to do a line here. So that's how I've turned this equation into, or this worded text into this equation. I said I've got three 3-volt batteries, so I went 3x. Oh, so x 3-volt battery, so I went 3x. I have got y 6-volt battery, so I went 6y. Now all I've got to do is substitute to see if I can get enough juice. I can tell you straight away we're probably going to have enough juice, but we'll do it anyway just so that we can do it properly. So how do you do it? What you would do is you would go, here we go, 3 times 3 plus 2 times 6 plus 6 times, substitute y equals 2. And is this greater than or equal to 12? The answer is 3 times 3 is 9, plus 6 times 2 is 12. So we end up with 21 is greater than or equal to 12. Yes, it is. So therefore, this will activate the battery. The circuit will activate because we've got more than 12 volts. So that would work. And that's how we can substitute these things in. And the whole point of this section here is to check the values in the region. So this is actually what I would usually do as a check at the end of a question. It's a really good way to just say, did I draw this correctly? Did I get it right? Because you can pick any value and you can be like, well, if this works, then the number on the left, this statement should be true. 21 is more than 12. So yeah, the statement works. I've got a question. So what happened to the drawing pad thing that you had? Did the school take it back? No, the school didn't take it back. That's a good question. I would kill, because look how ugly this text is. Drawing pad thing, which was amazing, is at school. And a lot of the teachers have been asking Miss Panasiris, can we go back to school so that we can just pick up our supplies? And because the department, remember that one person that was sick like 2 weeks ago, they still haven't finished the contact tracing for that one teacher, that one person that got sick. And so because they haven't done the contact tracing, even though it's like by this point in time, if they were sick, they would know it, we can't go to the school. And it's really annoying because it's like a lot of us teachers just want to go pick up our materials. And there's been a lot of students that have contacted Miss Panasiris for the same reason. They want to pick up their biology textbook or whatever. But because the government said no, she has to say no, which is fair enough, but it's still annoying. So I'm like waiting for us to be allowed to go so I can go in, pick it up. Yeah, it's annoying as hell. Okay, so where are we at? Okay, so we're about 9:30. We've got the big one here. Can I get you guys to draw in a Cartesian plane up, and then I would like you to write down 4x takes 5y is greater than 20. And what we're going to do is I'm going to show you guys how to draw that. And then I might see if there's time to do one more question, but I would love to draw this one. And we're actually going to do a lot of it. I'm going to try and do more than one example for you guys for this. Probably another one on Tuesday, but yeah, get this copy down, and I'm going to set up my little writing pad on the left here, and then we're going to do it together. All right, here we go. Yeah. So now the question that we're looking at here is 4x minus 5y is greater than 20. Now, how do we do this? Well, what we need to do, let me make this nice and big because I can. Obviously, I doubt that you guys would make it the same size. 10 centimeters, we'll do it. We'll go a little bit past 10 centimeters, but then we'll do a dot at every centimeter. There's 5. 5 is here. So I probably should have done this while you guys were, copying stuff down, but that's okay. Okay, so what we need to do first is we need to say, well, what is this? What does this mean? Well, 4x take 5y must be greater than 20. Okay, so we can still rearrange this to make a little bit of sense. Now, I'm going to be very, very careful with the negative here. So negatives do a weird thing when it comes to equations. So you're going to be careful. So if I have, and I'm going to work down here for a sec, 4x take 5y must be greater than 20. What I can do is I can subtract 4x from both sides. Now, if I subtract 4x from both sides, that's going to cancel that 4x here. And that's going to give me negative 5y must be greater than 20 minus 4x. And so far, that's fine. I can move terms from one side to the other. What I'm going to do now is I'm actually going to save one of these steps to the very end, but I'm going to show you. I'm going to divide both sides by 5. That's going to give me negative y is greater than 20 divided by 5, 4, minus, well, we're just going to go 4 over 5x. Now, here is the only part that you've got to be really careful with. In fact, I'm going to double check this at the very end just to make sure that I haven't made a mistake. I feel like I'm about to make a mistake, but I'll definitely show you guys. When you divide by negative 1, what you would normally do is that would then change this to be y, that would become a negative 4, and that would become a positive 4 over 5x. But there's one extra thing you've got to remember. When you divide by a negative, it also swaps the direction of the greater than or less than. What happens is that when you change the sign, when you divide the whole thing by a negative, it goes from y is greater than to y is less than. So it swaps. So that's something to be careful for. So we end up with the equation y is less than negative 4 plus 4 over 5x. Now, we can't plot inequalities like this, but what we can plot is we can plot this, or we can sketch this. Y equals negative 4 plus 4 over 5x. So let's plot that in. So let's plot this in here. So we've got -4, y equals -4, so that's the y-intercept, C, and 4 over 5, that's going to be m, which means m is going to be a, can you guys see that? No, you guys can't see it all the way down the bottom, sorry. I've got, oh man, stupid box. I've got m equals equals 4 over 5, which is going to be a rise of 4, a run of 5. I'm sorry, I know that you guys can't see this very well. So that's going to be useful, plus the y-intercept is going to be useful. I'm going to start plotting this. And I might move that back up to the top so you guys can see it in a sec. So here we go. Let's see, -4 from my y-intercept, -1, -2, -3, -4. Here is our y-intercept at -4. Done. Now my gradient is 4 over 5. So it's got a rise of 4, 1, 2, 3, 4, and then a run of 5. So if I do a run of 5, that's going to be 1, 2, 3, 4, 5. That point there is going to be 5, 0. And then what I'm going to do is I'm going to join these up. I'm going to join these up with a line. What I'm going to do is I'm going to make that line a dotted line. The reason I make this a dotted line instead of a solid line is because I want to make sure that because of this reason here, it says greater than 20, or in this case it says less than this number here. So because it doesn't say less than or equal to, it means the line is not included. So I'm just going to do it as a dotted line. If it says greater than or equal to, that's when I would draw the line. I've got a question here. Maybe I'm going too quickly. Maybe someone's got some. Do we have to add all the I's into the dotted line? Yes, of course you do. Yes, because, and I will do that here, because this line does still go on forever. So now the last part here, and there's a couple of parts you can do this, is a couple of ways you can do this, is to figure out which of the, is to figure out what to shade and what not to shade. That's right, I forgot. So what do we shade and what don't we shade? So how can we figure that out? Well, the easiest way to do it is to look at 0, 0. You can take any number you want, but I prefer to take 0, 0. How do I do that? Well, what I do is I go, let x equals 0, let y and y equals 0. So then that means you get 0, 4 times 0 minus 5 times 0 is greater than 20. Is 4 times 0 minus 5 times 0, so is 0 minus 0 is greater than 20. Is 0 greater than 20? No, it's not. So that means that this here is not, so 0, 0 is not in the region required. So if 0, 0 is not in the region required, what I do is I go, well, I'm going to cross it out. This is not the region I care about. I don't care about anything in that region. The only region that I care about is this region here in this bottom corner here. And so therefore, I do a little box. I'm going to do one little box probably here. And we'll write down, I'm going to do this. I'm going to write down region required. And then that's it. That is now the inequality. Now I can actually then choose any value. Let's choose this one here. So let's go 2, -4. So if I substitute 2, -4 into this equation, I end up with 4 times 2 minus 5 times -4. must be greater than 20. It's going to be 8 plus 20 is greater than 20, which means that 28 is greater than 20. Yes, it is. And that's why this point here is in the region, whereas this point was not in the region. And you can even compare these values with this down here. If y was 0 and x was 0, you would end up with 0 is -4 is greater than 0, which is not, doesn't make sense. So this should still work with these values, with this value here as well. -4, yeah, it should, yeah, that should work for this one here too. So that one works as well. So that's how you, what have I got for time here? That's how you plot with 2 dimensions. Okay, so what were some of the things that I wanted you guys to recognize? The first is that you've got to take your equation and make sure it's in the form of y equals mx plus c, and then you have to turn that into an equation. That gives you the line. And then I usually just choose a random point to then help me figure out, well, which side of this line is shaded and not shaded. There are other ways you could do it. The other way you could do it is to say, well, see how this says y, see down here how it says y is less than -4? What you can do is you can say, well, therefore the region that we care about is less than y, so it's underneath the line. But that can get a bit confusing, so I don't recommend doing that, but it does work. Are there any questions about this, or do you want me to move my hand so you guys can see everything? Do you guys want me to go back over anything, or can I just maybe do the last worded question?
It's good.
Wow. Could I take it? Someone's asking if I can take a picture of this and upload it. Yeah, sure. What if I do this? Yeah, I'll put that up later. Cool. So next, last but not least, let's give this worded question a try, shall we? We've got about 5 minutes left, so I'm not sure that we'll get through all of it, but we can give it a try. A barge will sink if its weight exceeds 25 tons. So a barge is like a boat that carries things. In this case, it's carrying cars. The average car weighs 1 ton. The average 4-wheel drive weighs 2 tons. What does it want us to do? Oopsie. Draw a graph to assist sailors in knowing how many vehicles they can place on the ship. Okay, so I'm going to do this one, and we're going to try and give it a crack. And we've really got, 5 minutes left, or 4 minutes left, probably less. So if I don't get through all of it, then let me know. If you guys need to leave, then shout out. I'll just close early. But I'm going to put this up now on. I'm going to cast this again. So if you guys want to, I'm not going to get you guys to write this down because there's no pencil. It's probably going to take you too long to write down anyway. So we're just going to do this one anyway. So I'm going to write down the important facts here. I'm going to give it a try. So we've got a barge. The barge can hold 25 tons. If it holds more than that, then it sinks. More than, and it sinks. So that means that whatever is on the barge must be equal to 25, either be less than or equal to 25. Okay? Let me just double check the question actually. It said exceeds 25 tons. So if it has 25 tons, it's okay. But if it goes over 25 tons, then it's then the barge sinks. We've got four-wheel drives, we've got cars, which we'll refer to as A. And then they're 1 ton, whereas four-wheel drives, which would be B, they're 2 tons. So we need to find a way to add up all the weight. So how do we get the total weight? Well, if we have A cars plus 1A cars, because I'm multiplying this by 1 plus 2B, that's going to equal the total weight. Think about it, okay? So if I had 25 cars, 1 times 25 would be 25 tons. If I had 1 car, 1 times 1 would be 1 ton. If I had 10 four-wheel drives, 2 times 10 would be 20. Now this weight must be less than 25 or equal to 25. So that means that 1A plus 2B must be less than 25. Because if this goes over 25, with the ship will sink. And we don't want the ship to sink. That'd be really bad. Now, yeah. So now we've got an equation. We can actually now start to plot this. So let's call how do we do that? Well, what we would do is we'd say, well, let's go with 2B. Let's just go with 1A plus 2B must be equal to 25. What I would then do is I'd then go 1A, and we would go 2B equals 25 minus 1A. And then I go B equals 25 over 2 minus A over 2. Then I can just do a quick little plot. What time have I got? 9:46. Pretty much out of time, but you know, let's give it a red hot go. Let's call this B. Oh, you know, bit of a moron. Why am I a moron? You can't have negative four-wheel drives, so it would have been just as smart just to do this. So this is B, this is A. I'm looking at this as Y equals MX plus C, so that's going to be a half A. So what's the y-intercept at 25 over 2? So 25 over 2 is, let's go here. Let's go that 25 over 2, so that's 12.5. And then here we've got a gradient of a half. That means we go across 1 and down, across 2 and down 1. So that gives us this point here, which is going to be 11.5 or whatever. The graph is going to look like this. Obviously, we're not going to go past here. Why are we not going to go past here? Because A must be greater than 0, B must be greater than 0. It doesn't make sense to have greater than or equal to 0. So, because you can't have negative cars. Now, the idea is that the region required is this region down the bottom here. Why? Because if you substitute 0, 0 into this equation, this should be a dotted line. Good job, Mr. Greer. You already stuffed up the very first thing you taught them, which is to always draw a dotted line first. But yeah, hopefully you guys can appreciate I'm doing this rather quickly. There you go, dotted line. And we want and so this case, the region required is still this bottom part here. How do I check that? Well, I could easily just check that I could easily just check that by substituting 0, 0 how could I check that? I could substitute 0, 0 into, where is it? This equation here. 0 plus 0 must be plus 2 times 0 must be less than 25. In this case, 0 is less than 25. Yes, that is correct. 0 is less than 25. So that works. Oopsies. And what time have I got? That's it. That's the end of the lesson. So that's how I created this graph here. Then the bottom, which you guys can't see very well. But yeah, that's just an example of how you can take a set of instructions like this, turn it into an equation like super quickly, turn that equation into an inequality, and then plot the equation and then draw the inequality in. I'm going to put this up online. What we're going to do is on Tuesday, we'll go through another example just to really cement this stuff in our heads. And then I'm going to give you guys the rest of the time to work on 12D. But that's going to be the goal. You guys have let me just stop this here.